everybody. It's just gone 11 o'clock on a Wednesday, which means it's once more time for the Oceans Institute live stream with a marine scientist. I am Tina, your landlocked, thalassophobic, land-loving host, and today it's a bit of a special episode. We have a crossover episode with James Dingley from Atomic Frontiers. Hello, James.
Hi, thanks for having me.
Welcome to the show. So James is actually a very special guest. This is part of the show where I normally reel off your CV, and you've got actually quite a frightening CV in front of me. So James is a Bachelor of Philosophy student. He is also a researcher. He's done projects in space technology, ocean engineering, and medical tech. And he is also a rising star in the YouTube scene with his channel Atomic Frontiers. He's been making videos and science communicating since year 7.
Year 7, yes, that's when I started.
So this is actually quite an intimidating show. We'll try and keep up with him. As always, we're going to get to know James pretty well over the course of today. You're very welcome to drop your own questions in the chat log on the side at any point. We are moderated today by Rob Pemberton, the regular OI Sea Monkey, who will be looking through and finding questions during the show. But we'll start us off with a nice, easy one. So James is a Bachelor of Philosophy student. He's actually the first Bachelor of Philosophy student that I've ever met. It's a pretty unusual degree. First of all, what is it and what made you choose it?
Yeah, so first of all, a common misconception of the Bachelor of Philosophy degree is that it's not actually anything to do with philosophy, though it does have a few similarities to it, in particular through the research side of things, and also particularly in lockdown times, when for the last week I've been walking around my house in nothing but a bedsheet made to look like a toga. But apart from that, so yeah, it's a research-intensive degree, and the idea behind that is to do a bit more in depth about what your studies are about. Mm-hmm. So rather than just doing an engineering degree, you look a little bit more into the research side of things.
So I have this impression of BPhil students walking around navel-gazing all day long, writing useless diatribes on the human condition. Is that not accurate?
It's not completely accurate, no. But useless diatribes about other subjects.
Okay. Useless diatribes. So what kind of projects are you working on at the moment? I listed a couple, but I have a feeling you're doing actually quite a lot more.
Yeah, so sort of my key focus at the moment is with the Bachelor of Philosophy, we're required to do a research year, basically. So that's one extra year on top of the 3 you already have for your undergraduate. And within that, I'm looking at how laser communication on Mars might work. So I will be aware that we have radio communication for the Curiosity rover to talk to orbiting satellites. The idea, though, is we could improve that link by using a laser. So it's going to be much faster, much less power requirements. But my research is looking into some of the problems that we might be facing if we did that.
So that's the space part of today's show, Space, Sea and Subs. Can you tell us more about the work that you're doing in ocean engineering and ocean research?
Yes, so at the moment I'm continuing some research I was doing over the summer break. That's with some of the researchers at the Institute. Mm-hmm. And I'm looking into how boats might be able to float next to each other and some of the issues associated with that. So if we have a big vessel that's taking up a lot of oil or liquid natural gas, that's got to then transfer it to a smaller vessel to take it to shore. Cool. But when you have that, there are some issues that there might be really big waves and they might crash into each other. So I'm looking into validating some computer models using some really, really, really big physical models in a massive wave flume that the Institute has.
Awesome. I think you did actually include some photos for us to show. Is this a good time to bring up the photo of the big vessel in particular?
Yes, so that's the...
Okay, I'll just bring it up just so that people know, because I don't think most people know the type of boats that you're talking about. I'm thinking about yachts and sailboats and Matilda Bay, but I have a feeling you've gone a little bit bigger than that.
Yeah, so if you got the vessels up now, do you?
I'm just about to bring it up. There we go.
Awesome. Yeah, so we see the small boat, or the one that looks small. That's actually some of the massive, sort of the same size as the cruise liners, or even bigger, that you'll often see in like Fremantle.
So the small boat, that's the white one with the round ball things on the top.
Yeah, exactly. So those round balls are what hold the liquid natural gas, and it's sort of the optimum configuration to hold that in.
I used to be a chemical engineer, I should know. So the liquid natural gas, so that's what's pumped from the seafloor.
Yep.
Okay, and that's stored in the round things on the back of the Ruby Princess.
Yeah, exactly. But then it's the big red vessel is the one that actually extracts the liquid natural gas and does some preliminary processing for it before it's then sent on to the smaller boat and then off.
So I get a sense of what this is now. So big boat, gets the gas, small boat transports the gas. And then what are you studying?
Exactly, yeah. So we're not really sure how boats float next to each other when they have that large a scale. And we need to know, especially if there are big waves coming in, if they crash into each other. So in order for us to get a better understanding of how that system works, we've made some computer models, and it's my job to validate those computer models. So you can make a model of anything, but you need to know it's actually going to work.
Mm-hmm.
There are two ways we could test if it was going to work. We could actually have these boats and put them in a really big bathtub and give them all these different storm conditions. But if you sink BHP's billion-dollar vessel, you might not be too popular.
And that's a big bathtub.
Yeah, very, very big bathtub.
Oh, I've got a question just come in through the chat log, actually. What prompted you to conduct this research about the boats?
Yeah, so over the holiday, I decided to work with the ocean researchers, and that was just one of the projects they had going. I'm quite a practical person, I feel, but I also really like the computing aspect of things. So this was a really good way to combine the two to see what computers are useful for, but also to get to do some building. So I'd spend weeks at a time stuck in the UWA Maker's laser cutting room. I'm probably breathing in an unhealthy amount of formaldehyde fumes as I was just cutting these big pieces out to make the boats.
Oh,
and today the boats are about 2 meters wide, about 1 meter across, the ones I'm working with. So it's a lot.
It's a very practical Bachelor of Philosophy that you're doing.
Yeah, you could say that.
So I guess you were talking about how a Bachelor of Philosophy allows you to do a breadth of research topics. We've just covered the sea and space. What else are you working on?
Yeah, so sea, space. I also do a lot of work with the UWA Aerospace group. So basically, a group of space geeks. We went to UWA, and when we were here, we really want to do something to do with space. But as I found out in year 11, when I wrote to the dean to try to get us a space course, students in year 11s in particular can't actually decide university curriculums. So
that is a shame.
Yeah, it is.
The world would be different if it was all just described by year 11 students. There would be no maths.
Oh, that sounds wonderful. Yeah.
It'll be all maths.
Oh dear. Yeah. So because we didn't have a space course that was sort of given to us in the university, we decided to make one ourselves. So the university gave us the basics, the foundations of it. Like they taught us maths, obviously, how to do computing, what material properties there are. And we applied those to the context of rocketry. So nowadays we design, launch, and test rockets to go to up to 5 kilometers and many times the speed of sound.
Let me just bring up a photo of the UWA Aerospace team, because I think recently you did something quite exciting. So you mentioned that there isn't an aerospace course at UWA, but you are all obviously UWA students. What kind of courses are you studying?
Yep, so it's a big variety. We have probably the main ones are in our engineering, so mechanical, electrical engineering. And we've got a few computer scientists, and they do some really amazing work in terms of the flight control systems. Honestly, some stuff that's just light years ahead. I understand barely any of it, but it looks really cool. And then we have some physicists who help with the simulations and in the modeling side of things.
Exciting. And this is just all on the side. So James Dingley, very busy. You're working on your Bachelor of Philosophy, which is finishing soon?
Yes, I finish in June next year.
Well, congratulations, I guess, for 1 year's time from now. And you've got all your work that you're doing. But on top of that, you're also working on Atomic Frontiers, which is your YouTube channel. So that's the logo that we have at the very top, the yellow. What is that? Is that an atom symbol?
Yes, it's a very unscientifically accurate atom.
So I do have to ask, Atomic Frontiers, where did the name come from?
Okay, interesting. So when I started out making videos, I always branded them as this is James Dingley from the Discovery Channel, or this is James from the History Channel, because I always really wanted to be a Discovery Channel or a History Channel presenter. And that was sort of my way in. But then I had a few people watching it and they're like, you're not the History Channel. They wouldn't employ you.
So you were committing some kind of light, I won't say fraud, but it was misleading the public a little bit.
Yeah, you could say that. So I decided I need to have a name. So what sort of channel would I be?
So was this all back when you were year 7?
Yeah, so this is year 7 when I started making these things.
Goodness. Wow. So James from the History Channel, James from the Discovery Channel, and then one day James from Atomic Frontier. Yeah,
so the way I actually picked that name is I'm terrible at coming up with names, as anyone who's seen any of the rockets that I've named can attest. So I got out a science magazine that I just had on the desk next to me, and just flipped through and I'd put my finger on a random word. I was like, this word will be might be the science channel or whatever. The first one I clicked was, first one I hit between was and the. I was like, and the is a terrible name for a channel. And the next one was
James and the channel.
Yeah, that sounds really good. But yeah, the next one was Atomic Frontier. It was between the two, and which is a combination of words I've never seen since, in terms of like just reading through things. But yeah, and then the name sort of stuck. Stuck.
And you actually have quite a number of oceans-related videos on there. So my question is, what, I guess, sparked your particular interest in science communication, particularly around the oceans?
Yeah, so I think obviously living in Perth, the ocean is really all around us. We see it pretty much every day you go outside. And so it was obviously there and a big thing. And then I'm particularly interested in extreme engineering. So you're doing an engineering thing that's in a really weird context.
Hence the space interest and the ocean's interest.
Exactly. So so the ocean's a really good place for that. So you've obviously got the wave forces, you have extreme pressures when you go down. And you've got the effects of water on different structures.
Awesome. So do you have any, I guess, stats for the rest of us who perhaps don't have a good picture of how extreme things can get? I'm, as described, a thalassophobic landlubber, so I don't go beyond Cottesloe. So how extreme do things get? What's extreme about the sea?
A good one, I think, is on pressure. So if you go to space, if you go to the moon, the maximum pressure difference you're going to have between you and your spaceship and then the outside vacuum of space is 1 atmosphere of pressure.
Right.
So that's the 100 kilopascals, the pressure you have between us here on at sea level. In the ocean, you get to 1 atmosphere of pressure every 10 meters you descend. And given that the Mariana Trench is about 11 kilometers deep, that means we have like 1,000 atmospheres of pressure on every single point. So there's a huge amount of difference between that. So
that's amazing.
If you go down a small bit, it's horrible to build in.
So it's got the pressure, and you're talking about the wave forms as well. On that ship that you showed before, do you have an idea of quite how strong or how big the waves we're talking about? I'll just bring up the ship again. The one that was the not quite Ruby Princess.
Yeah, that one. Yeah, so I know on my model, which is 1 to 100 scale, I'm not sure the actual scale, but yeah, so it's the waves I'm throwing at it are about 10 centimeters high, but that's on a thing that's 1 meter across. So when you have the actual one, it can be like tens of meters, some of the waves that we might be experiencing. And that's just in your normal sea state. When you get to more extreme storm conditions, which is when you would never ever have a docking between the two vessels, they can be even stronger than that.
That's crazy. Hey, this brings us nicely to a question that just got dropped in the chat log from Mariam. Mariam wants to know, regarding your modelling experiments, how did you find the modelling part of the project and dealing with the physics behind it, given you have done a Bachelor in Philosophy?
Yeah.
So how do you, philosopher, deal with hard numbers?
Yeah, it's true. So my actual Bachelor of Philosophy degree, I should probably clarified, I'm doing a double major, one of them in mechanical engineering, the other one in finance. Finance is completely useless in terms of how to model things, so we'll ignore that for now.
But very useful in other ways, kids.
Yeah, it's very good. Helps you do your taxes. But the engineering side of things, a big part of engineering is about modeling and being able to do a small scale test and apply it to a really large scale situation. And we do that through a few dimensionless numbers, so like the Reynolds number or the Froude number for Froude scaling. And so these are numbers that relate a certain fact about an object, so maybe its mass, to things like surface tension or the fluid density, stuff like that. And so if you're able to match these very specific numbers between the two situations, so you make this object here 10 times bigger than this object here, but this object here you have 10 times thicker fluid that it's being tested in, the conclusions you make between the two are actually applicable. So I was able to use Froude scaling, which is to do with wave characteristics, in order to match the two models together.
An issue with that. Mariam's question, how did you find the modelling part? Fascinating, it seems like.
Yes, I really, really enjoy that. That's fair.
Fantastic. We have a question about your channel again, Atomic Frontiers. So this question from Jamie. I love the video on how whales can help climate change. That's more of a comment. Let's talk about that video, because that was a more recent video, I think.
Yeah, that was the most recent one we published. So the idea behind that one is looking at alternate ways to solve climate change.
Mm-hmm.
And the way that we looked at specifically was how many whales would it take if we wanted to fix climate change with just whales?
How many would it take?
I think it's a couple of billion. If you lined them up end to end, you could wrap it around the Earth to the Moon, and then about a third of the way to Mars. So it is an unseemly, ridiculous number of whales. So it's not quite as practical as we'd hope, but the idea is to get people thinking about alternate ways to fix climate change beyond just the standard cut back, don't drive as much.
Excellent. So I think let's not spoil that particular video. If you're interested, Jamie and other people, do watch that video. We'll link it in the description after the show. Jamie just said too many whales. I think that's pretty much a good assessment. I think that would probably be more whales than we currently have on the planet Earth.
Very, very many more. Yeah.
Many more. Okay. So let's not rely on whales to solve climate change. This brings us back nicely, I think, to your video and particularly the ocean content. You do actually have a series called Perth Science, is that right?
Yeah, that's correct.
So Perth Science, I guess that's local points of interest. Are there any particular, local points of interest for ocean science that you can recommend that we check out?
Yeah, so I think we've got a picture of this as well. The Sorrento Shark Barrier.
Okay, the Sorrento Shark Barrier. Let me just bring that up. Okay, let me just get rid of that one. Mm-hmm. Is that it?
Is it the one with me with the big fins and the...
It is the one with you with the big fins and the shark net in the background.
Awesome. Yeah, so you'll remember a couple of years ago how there was that stream of shark attacks going on. We'd have basically one every 2 weeks.
Yeah.
So in that period, the city of Sorrento, Stirling, whoever owns that area, really wanted a way to allow beachgoers to swim and enjoy the water without the risk of shark attacks, because that was impacting like tourism numbers and the willingness of residents to go visit the beach.
Mm-hmm.
So they're looking at different ways in order to fix that problem. So the way they do it over in Sydney is they put massive actual nets over beaches. And that, unfortunately, although it does stop some sharks, it doesn't stop all of them. And the way it does that is actually capturing them and then killing them, which isn't a really pleasant way to deal with these things. We've got to remember we are going into sharks' sort of native territory, so we don't really have a right to just kill them because they're convenient. So they were looking for a different way in order to do that. And so local inventor Craig Moss, who I was fortunate enough to get to meet, he came up with this new shark barrier design that actually makes a physical wall and to stop the sharks getting in. And some of the interesting spin-offs from that we looked into in the video were that not only does it stop sharks, but it also provides a really good place for sea creatures and sea life to grow.
So I'm interested in, I guess, the backstory of this. So was this something that you just heard about through the grapevine and you decided this would make a good topic? Or did you set out to do a particular topic and then you found all the people that you needed? What's the normal process for a Atomic Frontier video?
Yeah, so the process really varies. For the shark one, it was a place that, because I live not too far away from Sorrento, so I wanted to know for myself, really, does this thing actually work? So I was confident.
Are you safe swimming?
Yeah.
So the way you chose to do that was to go in and see if you were safe or not.
Yeah, exactly. You see sort of the opening shot of that video. I'm in the middle of the ocean, far away from everything. Typically, if there wasn't a barrier, I wouldn't be swimming there. Mm-hmm. But by that stage of research, I was pretty confident it works. But yeah, there are a few different ways which video comes about. We can have, sometimes if it's a location I really want to visit, then I'll often make a video that sort of validates me going to see this cool location.
I think we've got a couple of examples here. Let me just try and bring one up for you. No, that's not it. So I'm bringing up a couple of photos. One of them shows a dome-like structure with some kind of building inside. These are all photos that you fortunately got to take in the course of your video making. There's another one, I think, which is very beautiful. Is that a cave with a waterfall?
Yeah, so that's in Swindons Hole in the UK. Basically did a video on Martian colonization and looking at a different route to do it through the caves rather than just on the surface.
And now I'm interested.
Yeah. So in the course of filming that, we saw some really amazing, remarkable places. So you spend maybe like 3 hours going through these really tight, narrow squeezes that give you claustrophobia just thinking about them. But it was all worth it at the end because we opened out into this massive underground, essentially beach. We have a waterfall coming from the roof, a little bit of sky, the sun coming through, little beam and stuff.
Oh my goodness!
So it was really, really amazing.
And so the topic for this one, you mentioned something around the colonization of Mars. How does that tie in? Yeah, I'm struggling to see the connection between a small cave in the UK and Mars.
Colonizing Mars, yeah. So there are quite a few issues when you try to colonize Mars. Probably the key ones being that it's really, really cold on the surface, and that there's a lot of radiation. There's very little protection for the planet. Mm-hmm. So on Earth, we have the magnetic field, which helps to protect us from solar rays and radiation. But on Mars, they don't have a magnetic field. The reasons for that we go into a bit more detail in the video. But essentially, Mars doesn't have any of this protection. And so in order to live, we need some sort of other protection. And we use many meters of rock to do that. And Mars already has all these caves that are specially built, not just for us, but they are there existing that we can use. So the idea being that we could go live in these caves potentially.
And this is just one of the very exotic locations that you've been to in the course of your series. In your background, I think you can just see a world map.
Yes.
With some little dots on. Talk us through your journey.
Okay, so my most recent adventure was through Europe. So as part of the B-Field program, we have to spend a year or have to spend some time studying in a different country. Mm-hmm. So I decided to study in the UK. And when I was there, I made sure to make as many trips as I could around Europe. So I went to Paris to talk about the catacombs and potentially using bones to build human structures in the future. We went through Italy. We went to to see the Pope and the idea of different types of smoke we might be able to use to signal the new Pope mm-hmm. being accepted. We talked about the Leaning Tower of Pisa and some methods that have been used to stop it from falling over. And because I really like doing experiments in as well as just talking about things, for that one, I went to the chemistry department people and asked, could I borrow many, many, many liters of liquid nitrogen? So we use that to freeze a bunch of soil to stop our own Leaning Tower of Pisa from falling over. So that was quite
That's
fun.
Very exciting. So you clearly have interest across a wide range of topics. A general question I have for you is, when did your interest in science communication begin? It's a question that I ask lots of science communicators. Was there a single moment? Was there a slow boil? When did you start to realize that this was something that you were interested in?
I think it was probably a slow boil, probably mm-hmm. partly from my parents not letting me watch any like Pokemon or animated things, but really? Always giving me documentaries to watch. So I think that definitely had an effect. Seeing the amazing science museums around America and Australia also probably helped. Mm-hmm. So it's always been like a thing I want to share with people, that this amazing thing called science and engineering that let us understand and influence the world. I want to sort of share how amazing that is, that this thing exists that we can use.
That's a beautiful sentiment, James. There's a question for you from Rose in the chat log. Rose wants to know, what sort of videos can we expect for the future of the channel?
Okay, so I have a whiteboard over there with about 8 to 10 videos that I have filmed but haven't yet edited. So I can tell you that the next video is on, it's filmed up at Broome and looking at dinosaur footprints.
Oh, very cool. I might be able to bring that one up as well. Let's have a look. So I'll just try and bring up the dinosaur footprints. This is really interesting. So this is another local-ish landmark, I guess. So obviously no one can visit it now, but in the time after COVID, when intra-state boundaries are open again, I'm sure we'll be able to get up there. So I'm just showing up the picture of dinosaur footprint up in Broome.
Yeah, so there are these amazing sort of beaches up there that have these rock formations on them. And if you look really carefully, you can find these. The one I've shown there is quite an obvious footprint from a carnivore dinosaur, but there are also some Diplodocus ones around there that if you didn't know what you're looking for, they're just like round, flat depressions. Mm-hmm. But they're actually the footprints from dinosaurs that walked through these lands millions of years ago.
So that's one. Are there any more oceans ones coming?
Ocean ones. Oh, I'm trying to think. I have filmed a few ocean ones. Can't remember what they are at the moment. I've got one about submarines that is in the works, so that should be quite exciting.
That's cool. So what motivated the submarine interest?
This was partly there's this amazing thing that is in Perth, this being the submarine that we have at Fremantle.
Mm-hmm.
I'm trying to look at what does this tell us about engineering and science?
So this is where I betray my extreme lack of local marine knowledge. What is the submarine in Perth, and what is it for?
Yeah, so it's an old military submarine, and it's just at the Maritime Museum down there. And they have it.
Should I go and do my research? That's a good point. That's really interesting. So that's coming up on the horizon as well. I have a follow-up question.
Mm-hmm.
How do you generally choose a topic? Because you seem to have such wide interests. Sometimes, as with the shark net, there's a story that I guess leads you in. But in general, is there a thought process behind that?
Yeah, so particularly with the early ones, it was always part of the Australian curriculum. So I don't always enjoy studying, but I found that if I made a video on some topic that I was having difficulty with, or that perhaps my peers were having some struggle understanding, if I made a video on that, that was a really good way to understand the topic.
Mm-hmm.
So yeah, definitely at the beginning, it was looking through the curriculum, seeing, okay, we're talking about wave interference and beat frequency. Let's do a video on bells and how we can make a better bell with the bell tower. Or it might be quantum leap and the idea that you can excite some atoms and they would produce a certain frequency of light. And then linking that in with fireworks, the Perth fireworks show. So that was definitely how it began. Then often it's a cool idea. So the idea of Mars colonization, and I'll try work out a place that can explain Mars colonization the best. So that's with the cave one that you showed a picture of earlier.
Mm-hmm.
But the key one and the way that I really enjoy it is you find a place that people walk past every day, probably don't fully appreciate, and show like this amazing story going on behind the scenes. So probably my favorite one of those is at the Koopa shot tower, which is...
Do we have a photo of that?
You do have a photo of that. It's the one with the weird dome structure.
The dome structure. Okay, I think I know. Let me try and find that. There it is.
So this is the Koopa shot tower. It's basically in the middle of a shopping centre, just in the Melbourne CBD. People walk through all the time. There is a clothing store actually inside the building itself, but no one really. I don't think anyone really appreciates what's the amazing stuff going on inside it. So walk past it and then took a close look at the building, asked the shop owners what was going on. They said, it's called the Koopa shot tower. We don't really know what it is. I then went to the State Library, which was fortunately across the street, and spent a full day researching this building. And through that, I sort of came up with a story behind it. So for those who don't know, the shot tower is used back in the colonial times. They'd melt a bunch of lead up at the top and allow it to drip through the roof. And as it did that, the lead droplets would form almost perfect spheres. And they'd use these really small spheres to help with hunting. They load it into shot cartridges and be able to hunt things if you can't aim correctly, essentially. So the video then took on this is a cool thing that exists. Is there one that exists at the moment? And there aren't many because hunting isn't nearly as popular as it used to be. But there is actually one still operating in Australia. And by a stroke of good fortune, it was just an hour's bus ride out of the CBD. So I went there, talked to the people who were operating the place, and then let me come around, see how it works.
Mm-hmm.
And then the final sort of step was like, okay, we have this thing in the past, it exists now. Could we use this technology in the future for anything? So for that, we looked at, okay, can we use microgravity to help build other things? And it turns out, yes, there is a special type of optical fiber that you can only make in microgravity. And they're actually building on the space station at the moment for some medical imaging.
Very cool. So this is a great example of, I guess, one tiny seed of information growing many, many different branches of terrifying paths that you can go down. I can see how quickly you might be able to spiral down into this science communication web of crazy.
Yeah, you could say that,
Yeah, you did say local landmarks sometimes do spark interest. I think there's one more photo that I'd like to show, which is the one of you diving. Is that a local one as well?
Yes, so this is the one with a funny bubble helmet on.
Yes, it's the one of you in the ocean with a funny bubble helmet. Let me try and bring it up. This one surprised me because obviously you look very exotic, but I then learned that this is actually somewhere a lot closer than I thought it was. I expected you to be somewhere in like California or back in the UK. But no, this is the one that's titled Into the Abyss.
Yeah, so it surprised me as well, actually. This one's down in Bustleton. So at the
Not
very
to
end.
the abyss, absolutely.
Yeah. So the end of the Bustleton jetty, so it's really long, a couple of kilometers long jetty. I think it's one of the longest ones in the Southern Hemisphere. Anyway, at the very end of it, where it's a little bit deeper, they have this essentially diving setup down there. So tourists can wear these really funny helmets you see in the picture, and you can walk around on the and you can walk around on the bottom of the ocean and
what?
as if you're back up on land.
That's incredible. How deep is that?
So that specifically there is, I think it's only 3 meters deep. So it's not quite the abyss, but it was a really good sort of excuse to talk about some ocean science, and particularly the technology that allows us to explore the ocean.
So that's really interesting. This is the part where you and I have some crossover interest because we're both ocean nerds, we're both space nerds, and it's interesting that you mention technologies and the oceans. I think there's an interesting crossover there because obviously extreme environments you're interested in, extreme environments on land or in the great beyond. But the other thing that's really interesting that we were talking about earlier is, of course, what you can see in the photo, which is the abundance of life in the ocean. Do you have any thoughts on that?
What do you mean by that?
So earlier, just before the show, we were just messing around and we realized that we're both fascinated by the idea of life in water and life and space.
Yeah, well, obviously really amazing to see all this life down there. They do a really good thing, particularly on the Bustleton jetty around that area, where they have these special mats they put onto the jetty pillar things, and they sort of promote the growth of different life down there, which is why it's such a really amazing place to snorkel around. Because I'm making a video, I had the excuse to spend about 3 hours just snorkeling around, taking some footage of the different life down there. So that was really good. But you sort of see, I think this is what you're leading into, is that wherever there is water, there is also some remarkable life going on. So what makes me really excited is hearing about the fountains of Enceladus, which is a moon around Jupiter. And we see with these fountains being caused potentially by liquid water, which might mean there's life down there. Similar, Europa, which is one of Jupiter's moons, we also think has a liquid salt water ocean. So I'm really excited to see how the marine science that we've done here on Earth might be able to apply to these other places when we're looking for life in these locations.
And if it happens, I think you'll be there to report it.
I'll be on the first crew across, yeah.
Yeah, so you were mentioning that you're doing a lot of research in space tech just as part of your Bachelor of Philosophy. Were you also hoping to do more research later on in your career?
Yes, so at the end of my Bachelor of Philosophy degree, I'm hoping to head over to the States, because obviously that's the real hub of space innovation design. So yeah, hopefully to head over there and do some more work on either propellant systems, which I'm quite interested in, or also the actual satellites that are using these systems.
That's very cool. Okay, so this is the part of the show where I think we're going to ask you the final question, which is the biggest question. You do obviously a lot of research, and you commit quite a lot of your time towards these videos. What are you actually hoping to achieve with Atomic Frontier and these videos? What would make you think I've made it as a science communicator?
It's a really good question. I think probably the key thing is that I really want people to appreciate how cool and amazing the world really, really is. So that people can go around and see, oh, that's a tower. I know why that exists and some of the science it reveals and the engineering principles behind it. That would be my real goal, to have people look at the world a bit differently. And by doing that, be able to change the world in a better way. So that's sort of the real big goal. But then one of my personal goals is to just see some really cool places. So because of making these videos, I've been able to go behind the scenes in different places. So like the Hellsborough Palace water gardens, which is made by this old Austrian duke. And he made all these like fun water gardens. So being able to go see behind the scenes, the like buttons that he'd press to spray his guests and be able to pull a few of the levers, that was really fun. Then I visited Svalbard, which was amazing. I had some people pay for me to go and visit the most northern town on Earth, which is that one at the very, very top.
Is that, which country is that in?
That's, it's not really any country, but I think it is being maintained by Norway.
Right. Is this where the seed vault is?
Yeah, exactly. So the original goal was to go visit the seed vault, but unfortunately it had flooded the day that I was scheduled to actually visit it.
I think for listeners at home, we might have to explain what the seed vault is.
Good point. Yeah, so the idea behind that is that we have all the different countries are sending different samples of their seeds. And these can be your crop seeds, so your corn, wheat, whatever. And now it's more also your native plants. And they do. So we have this reservoir of seeds that we can then, if there's a disaster, so if there's massive earthquakes or big tsunami, floods, that country can ask for their seeds back. So they can make a withdrawal and use their seeds to start a new generation and fix that.
So this is our backup of all the seeds. A collection of seeds that humanity can draw upon if and when we need it, which I hope we don't, but you never know.
No. I know a few countries have made withdrawals, particularly in war-torn countries where they've lost a lot of their fields. So it's being used, but the big thing is the big doomsday vault that we can all draw on. And it's kept up there because it's in the middle of nowhere. It takes ages to get there anyway. And the ground is all permafrost. So it means that they put the seed vault in the ground and the stuff will be able to survive. Even if they lose all the power, even if the world ends, we'll be able to use that.
We're just looking at a comment here in the chat log. It's quite distracting. Jamie would like us to know that these helmets are quite remarkable, and she's done the same in Hawaii. But Rob P wants us to know that helmet doesn't actually look very trustworthy. James' comment, how safe did you feel?
Less safe if you move your head forward, if you lean over to say look at a cool octopus or see some bit on the ground, because it's open at the bottom, the water comes in.
Oh.
So the water actually comes up over your mouth and even over your nose if you bend too far forward.
Oh, it's not closed.
No, so it's sometimes really terrifying if you lean over and don't think about it. Plus, it's really heavy, so it's difficult to get back up when you get into that situation.
So it's not authentic dive gear as such.
No, but that is in some ways quite a good thing. When I was there, a guy and his mum were there, and he's really into scuba diving, but the mum really can't deal with that. So it was really good to see them both doing this thing, which is honestly generally an easy activity that they could do together because of this technology.
Are you much of a scuba diver yourself?
Yeah, I really enjoy scuba diving, which is partly why I made that video to talk about some of their scuba diving technology.
So what's the coolest place you've ever dived, scuba?
Yeah, I went to Vanuatu once, which was really amazing. So really warm water, amazing sea life. You see the drop-offs which just go down and all these different corals growing. So yeah, really lucky. But even so, some diving at Rottnest that I've done has been incredible. So we live in a really lucky place, I think, here in Perth.
I think that's the one thing which has come through. Surprisingly unique ocean biomes around our coast, just on our doorstep. Yeah, definitely we should explore it. I'm going to throw it open to comments and questions in the chat log. You've heard about James's adventures. He's a very well-read young philosopher. I'll keep calling you that. With a wide range of interests, he's done videos on all sorts of topics. If you want to know more about science communication, if you want to know a little bit more in detail about the shark nets, Bustleton Jetty, or whales and climate change, now is the time to drop your questions in the chat log, or just any general questions about making YouTube videos and changing hearts and minds through the power of the visual medium, I think would be a good time to ask.
Sounds good.
They'll come flooding in, I'm sure. I'll just ask my favorite question to ask any guest. What is the worst that you've been seasick? What's the worst incident?
Oh, I'm actually really lucky because I think I'm immune to seasickness. So there is a boat that goes like an old tall ship, sailboat that goes from Fremantle, and that's called the Lewin. So back when I was in year 11, I was really fortunate to get an opportunity to spend a week sailing aboard it. And when I was there, we had the most rough conditions that they've experienced. When we were doing the rigging up top, you'd be swaying like tens of meters back and forth as you were doing that. So all of my friends at this time were very seasick, but I managed to avoid it, which I think is why they're such good friends of mine now, is because my mum gets very seasick. So she'd brought me a big pack of seasickness tablets just from the shops. So I was able to hand those out to people to stop them from getting seasick, which I think was quite
You're
fun.
very lucky. I am terribly seasick at all occasions. Hopefully the questions will come flooding in. Until that time, here's one. Joel. You may or may not be able to answer this one. It's it's quite a big one. How are the oceans doing with COVID going on? Has anyone had time to run any studies yet?
Yes, that's a really big problem actually with COVID, is that it's obviously really cool, interesting to see how the world responds to basically a world without humans in it. So there's lots of really interesting science that we could be doing, but unfortunately, in order to set up that science, it requires really quite a long time. And for example, I've just spent the last 3 months making a proposal to do a little bit of research. I'm not even doing any research myself. So it takes ages to get science approved. So unfortunately, we haven't really been able to set up any systems. We've had a few, obviously the existing monitoring stations are going to be quite useful, but they aren't tailored to the sort of COVID science that you'd want. In addition to that, we're obviously still doing a lot of sea freight and travel that way. So we've lost a lot of the cruise ships, but we still have the shipping containers and the oil and gas going through. So it appears if the oceans aren't benefiting that much from the loss of humans from COVID.
As you'd think, really.
Yeah.
There's a second question here from Sachio. What are some of the projects you've worked with UWA Aerospace?
Yeah, so we do some really, really exciting projects at UWA Aerospace. So the picture you would have probably seen earlier is with our rocket Finley. So we launched that one over in Queensland to an altitude of about 3 kilometers. And that was as part of a inter-university competition with universities from all around Australia coming in to compete. We managed to go quite well with that one. So we launched it. Our very first one crashed into the desert and we had to spend about all night trying to fix it up. But that was really, we ended up launching it. We did really well in the competition overall. So that was one of our projects we've done. We quite recently launched a supersonic rocket, which is our very first one to break the sound barrier.
That's cool.
We think it broke the sound barrier. We're pretty sure it did. The reason for that is because we actually lost it because I forgot to turn the GPS on. So we couldn't actually communicate with it after it launched.
So did you never find it?
No, we're still looking for it.
Oh, really?
We've got some satellites to look for it, which is a good way to actually meet some satellite people. So you take images from space and you use those images to look for what was a black and green painted stick, essentially, that we launched. So
that is literally searching for a needle in a haystack, though.
Yeah, it really is. We'll find it one day, but
one day. You remain hopeful. So next time, maybe turn the GPS tracker on.
Yeah, exactly. And then the exciting one we're doing at the moment is essentially we're bringing up a reverse rocket using a weather balloon. So we're taking up a rocket, having it pointing downwards really, really high to about 30 kilometers. And at that altitude, we have much lower pressure, which means less wind resistance. So you drop it at height, and then it falls for about 10 kilometers. And during that time, you have essentially zero forces on it, which means that you have it in free fall, which is going to allow Perth researchers and some Perth companies to do microgravity research without needing to go to space or to fly on the Vomit comet.
Oh, that's really interesting. Huh.
So we've got a lot of really exciting projects going on.
Okay, I've learned something new today, which makes it worth it. I've got a comment here from Jamie about sea turtles are nesting more successfully. So we were talking earlier about the effect of COVID on oceans and perhaps it being maybe a minor good thing, with fewer people obviously on beaches to disturb them. Then we have a question from Rob P, regular listener. One of your popular videos is about the Vasa.
Yep.
Vasa. Why do you think this video blew up? And any plans to do more marine archaeology videos in future?
Oh, I love marine archaeology so much. I've got a friend who does scuba diving on some Perth wrecks. So yeah, we definitely have some marine archaeology videos in the future, probably in the summer when it's a bit warmer. But yes, I'd be super keen to go back to that. As for why that particular video took off, I think it's because it tells a really interesting story. So the story of the Vasa, for those who aren't aware, is this really old ship. I forgot exactly what country built it, but they so built the ship. It was going to be the most powerful in the world, had all these extra rows of cannons.
That's a familiar story.
Yeah, and then they sailed it out, and then it sunk almost immediately after they launched it. And so the video goes through the sort of investigation they did in order to work out why the ship ended up sinking. I won't spoil it, but there was a lot of different engineering problems that went on to cause it.
So it sounds like it's more of an engineering interest that you have, as well as is it an anthropological one as well?
It's a bit of everything, to be honest with you. I occasionally show up to lectures that I'm not actually registered for, just to see what weird stuff different disciplines are working on. So I'm a bit of interest in everything, yeah.
Hey, it's almost coming up to time. I might just do one final call out for questions. Yes, last chance to ask James anything at all. He promises to answer. No, he doesn't. Otherwise, we'll say goodbye to you folks in about 5 minutes. In the meantime, I will drop you an emergency question. This is a question for us when there aren't other real questions on the table. What is your favourite sea creature?
Oh, I think it's got to be the blobfish. So, and it's a creature that I think is a bit unfairly treated in the media. So, for example, it's voted the world's ugliest animal.
We've all seen it. It's the one that it's like translucent and pink, sort of slimy.
Yeah, it's blobby. It's sort of all falling apart.
Yeah, and it's got a face like that sort of face.
Yeah, that's very much like it. That's good. Yeah. So really ugly animal. Except that where it actually lives, which is in the really, really deep, it's not ugly at all. How it survives in these extreme pressures of a couple kilometers down, which is like hundreds of bars of pressure down there. The way they cope with that is basically their cells are a bit more floppy than a bit more soft than the cells of creatures back on land. Which for these creatures down there, because of the pressure, they actually becomes a bit harder, a bit more firm, which means that it can function normally. If we were to go down there, our cells would stop working because of the pressure. But because they're a bit softer, it's able to go fine. So it works in its environment. However, when you're a fisherman, you bring up this blobfish, the soft material that it's made out of becomes actually soft when you get up to lower pressure, and it all just flops apart.
It all just flops apart, which segues me nicely into the chat log. It is all just falling apart, James. 2 questions have come in. Neither of them are acceptable, so I won't ask you at all. Moderator Rob, please moderate the chat. I think it indicates that we're coming naturally to the end of today's conversation. It has been a really nice conversation. We've covered a lot of ground and a lot of space and a lot of sea.
It's been really fun.
Yeah, it's been really great. If you're interested in catching up with James, do so on Atomic Frontiers. He's got when's your next video coming out?
That's a good question. Probably after my exams.
After exams, okay. So check again after exams, but rewatch all of the existing videos, and definitely watch the ones on oceans, which are James.
Yes, lots of them. Anyone blue on it is an ocean one.
Yeah, so watch the ones that we mentioned today. The whale climate change one, the Sharknet one, and the Bustleton Bay one, jetty one, and any other ones on there as well. I think it's time for us to wave goodbye to the lovely people. It's been really nice.
Thanks, everyone.
Thanks for joining us once again. We'll be back next week. If you're interested in anything else related to oceans, watch the other streams from before. We have Julia Reiser with plastics. We've got Taylor and Brett with corals and penguins. And then we also have the shark ladies. And of course, today we've covered a lot of ground. Thank you so much, folks. See you next time.
Bye.